Hello students, in this video we are going to discuss 3.7 from current electricity. Determine the current in each branch of the network shown in figure. This figure is nothing but a V-stone bridge. But this V-stone bridge is not balanced V-stone bridge. It is unbalanced V-stone bridge. Why? Means it is not satisfying the condition, balanced condition. Because 10 by 5 is equal to 5 by 10. According to balanced V-stone bridge, the resistance across AB divided by resistance across BC should be is equal to resistance across AD divided by resistance across DC for balanced V-stone bridge. But here it is not equal because 10 by 5 and here 5 by 10. So these two are not equal. That's why it is unbalanced. If it is balanced V-stone bridge, the problem will be easier. Here it is unbalanced. So to solve the problem, we are taking the help of Kirchhoff rules. Okay. So first of all, we are assuming that the 10 volt supply is giving the current I. This I at junction A splitting into two parts. One is I1 in AB branch and I2 in the branch AD. So here I is equal to I1 plus I2 as per Kirchhoff's current law. And at junction B, this I1 is splitting into I3. I3 is moving from B to D and the rest of the current I1 minus I3 it is moving from B to C. At junction D, this I2, I3 will combine together and I2 plus I3 will move from D to C. At C, I1 minus I3 and I2 plus I3 will combine together. Finally, I current will be coming out from junction C. Now, I am applying Kirchhoff's voltage law for loop ABDA like this. Now, the potential difference from A to B in the direction of the current I1 will be minus 10 I1. Why I am using minus means the potential is decreasing in the direction of current I1. And from B to D also the potential difference decreases. So this one will be minus 5 I3. And from D to A the potential difference increases. The potential difference between D to A is in the opposite direction of I2. So this one will be plus 5 I2 is equal to 0. I will write the same equation as if I am dividing with minus 5. This one will be 2 I1 plus I3 minus I2 is equal to 0. Take it is equation number 1. And similarly, I am applying the KVL rule for the loop BCDB. So applying KVL for BCDB loop. So what we can get here? So from B to C, the potential difference decreases. So I will write minus 5 times of, it is in the form of IR. So resistance is R into I1 minus I3. And from C to D, I am writing plus 10 into I2 plus I3. And from D to B, I am writing plus 5 I3 is equal to 0. Now, so after simplifying this equation, I will get minus 5 I1 plus 5 I3 plus 10 I2 plus 10 I3 plus 5 I3 is equal to 0. So 5 I1 here minus 5 I1, while coming to I2 terms 10 I2, while coming to I3 terms plus 20 I3 is equal to 0. I am again dividing this one with minus 5 completely. This one will becomes I1 minus 2 I2 minus 4 I3 is equal to 0. Take it as equation number 2. Now we are taking one more loop. So that loop is for AD C. I am writing this one is suppose say F, this is G. So AD C F G A loop. So I will write the expression by using Kirchhoff's voltage law. Here from A to D minus 5 I2, D to C minus 10 into I2 plus I3, and the EMF of the cell is plus 10. Y means we are moving from negative terminal to positive terminal, and the current passing through this 10 ohm is I. That I is nothing but I will write minus 10 I is equal to 0. And this minus 5 I2 minus 10 I2 minus 10 I3 plus 10 minus 10 into I value is nothing but I1 plus I2. I is equal to I1 plus I2. So I am using this one here, minus 10 I1 minus 10 I2 is equal to 0. So if you simplify this one, the in terms of I1 we have minus 10 I1, I2s we will have minus 10 I2, minus 5 I2, here minus 10 I2, we have minus 25 I2, and I3s we have minus 10 I3. I am sending this 10 is towards right, that is equal to minus 10. By dividing with minus 5 here, we will get 2 I1 plus 5 I2 plus 2 I3 is equal to 2. It is equation number 3. Now, by solving all these three equations, equations 1, 2 and 3, we will get I1 is equal to 4 by 17 ampere. Actually here we have three equations, three variables. The three variables are I1, I2 and I3. So if three equations with three variables can be solved. So after solving, I1 is equal to 4 by 17 ampere, I2 is equal to 6 by 17 ampere, and I3 is equal to minus 2 by 17 ampere. Here I1, I2 values we are getting positive. That means the current will be flow as we have shown here. But while coming to the current I3 we got negative. We have shown in this diagram from B to D. That means the current is moving from D to B actually. That's why we got here negative side. And the question asked is the current through each and every branch. Here currents in different branches. So the current through the branch AB is equal to I1 only, that is nothing but 4 by 17 ampere. There is no change here. At the same time, current through AD is equal to I2, that is also nothing but 6 by 17 ampere. So current through AB, current through AD directly we can write. But while coming to current through BC, current through DC, it is the combination of I1, I3 here I2, I3. So we can write current through BD is equal to I3, that is nothing but minus 2 by 17 ampere. So these are the direct. But while coming to the current passing through BC is equal to, we have I1 minus I3. So here I1 is 4 by 17 minus I3, minus of minus becomes plus, this value becomes 6 by 17 ampere. And current passing through DC, IDC is equal to, we have I2 plus I3. I2 value is nothing but 6 by 17 plus I3 value is minus 2 by 17, that is equal to 4 by 17 ampere. And the total current I is equal to, we have I1 plus I2. So that is equal to I1 4 by 17, I2 value we have 6 by 17, that is equal to 10 by 17 ampere. So this is the total current. So these are the currents in different branches. So this problem we have solved based on the Kirchhoff's rules, that is Kirchhoff's current rule and Kirchhoff's voltage rule. So, and this bridge is not balanced, it is unbalanced Wheatstone bridge. That's why the current is passing between B and D. In the case of balanced condition, the current won't pass between B and D. B and D will be at same potential. Now here B and D are not at same potential, they are at different potentials. Potential at D is larger than potential at B. That's why the current is moving from D to B. Thank you.